we look at some past year questions to practice on using the normal distribution table. Okay, this is the questions from May, June 2012, variance 6.1 and question 1. So see, it is given that X follows normal distributions. So this value is the mean, the mu, and this value, don't forget, is the variance, sigma squared. All right, to find the probability that a randomly chosen value of X lies between 25 and 30. Okay, so we're trying to find out the probability that the value of X lies in between 25 and 30. So the first step, we will always have to carry out standardization. So which means we are taking the X value of X. So let's say I put the formula at the side here. Z-score, X minus the mean divided by standard deviation. Okay, minus the mean 28.3 divided by square root 4.5. Remember, the value 4.5 is the variance, but what we want is the standard deviations. So square root 4.5, square root the variance, you get the standard deviations. Okay, another value of X minus 28.3 square root 4.5. All right, now we find out the values. So you will get a decimal number and you just have to round off this number until 3 decimal places. So I'm getting negative 1.556. So the second value is 0.8013, so 0.801. So why do we keep to 3 decimal places? This is because the table given can read up to 3 decimal places. Okay, so again, I'm sketching the bell-shaped curve here. Symmetrical in the middle is 0. There is a negative 1.556. So the value will be roughly here, negative 1.556, 0.8. So should be nearer to 0 on the right. Here, 0.801. So can you see we are getting the area in between these two values, and that will be the probability. So in order to get this probability, what we are going to do is to take this probability that from the table, which is like the z-score less than 0.801, the total area all the way to the left, minus the probability of the z-score from this negative 1.556. Okay, so now we look at the table 0.801. So this is an extraction of the table. First, we have z-score, read up to the first decimal place, 0.8. So 0.8 is here. Then we look at the second decimal place, 0. So the intersection is here, 0.7881. But not done yet. The third decimal place is 1. So from the smaller column here, the 1 is here, right? Then you will look for the value 3. So that means the probability we want is the, I put it at the side, on the left, 0.7881 plus with 0.0003. Okay, the 3 here doesn't mean just a 3, is 0.0003, and hence this is the value. That is the probability we want, 7884. Okay, now we are trying to get, so I put in black color. We're trying to get this region, and then we want to take the bigger area minus a smaller area here, so that we are finally getting the area in between these two values. All right, so how do we find out this area? So as you can see, this is a negative value. And when we read from the table, we can only read the positive value. All right, so let's say I sketch another bell-shaped curve here. So supposingly, I'm going to get negative 1.556. But the problem is the table would not give you the negative value. So hence, since the bell-shaped curve is symmetrical, I'm looking at 1.556 on the right. See? But the thing is, when I'm getting the value, the probability from the table, it would give you the value from positive 1.556 all the way to the left. Okay? But what do we actually need is the smaller area here. So in order to find out this smaller area, we will take 1 minus that the probability we obtain from the table. So now we just read 1.5, then followed by 5, and followed by 6. Let's see. So first 1.5, then the second z-score is 5. So their intersections here, 9394, and last value 6. So you are getting 7 here. So again, that means the probability is 0.9394 plus with 0.0007. Okay, so the probability is 0.9401. All right. So with this calculation, we are finally getting the probability of what the questions want. Okay. 7884. So the answer is 0.7285. And then we can read the answer as 3 significant figure. Okay, so that is the answer for these questions. And this is how we use the table to find the probability accordingly. Okay, let's see another example. So this is question from May, June 15, parent 6-2, question 7. Okay, once a week, Jack goes for a run. The time he takes in minutes has a normal distribution with mean, okay, and standard deviation both given, right? So like I said, in the exam questions, it must tell you that this is a normal distribution. So it has the mean of 35.2 and standard deviation 4.7, but I put a square here because this position is meant for the variance. Okay, in order to find out the expected number of days during a year of 52 weeks, for which Jack takes less than 30 minutes for his run. So first thing, we are trying to find the probability that he takes less than 30 minutes for his run. All right, so first step, standardizations. All right, leave the z-score to 3 significant. No, 3 decimal places. All right. Again, look at the bell-shaped curve, 0. And it's a negative value, so it's negative 1 point something, so negative 1.106. And it's less than. So since it's less than, it's the smaller area here. All right. So what do we do? Again, because the bell-shaped curve is symmetrical, you are not able to read the negative z-score from the table. So I will flip it on the positive side. And then we are looking at this region. All right. But as I mentioned just now, whatever given from the table will always be the bigger region, the bigger area here. So since in these particular questions, we are actually looking for the smaller region, I'm going to take 1 minus the probability of z-score less than 1.106. Okay, so let's see the probability. 1.1, 0, and 6. Z-score 6. This is 1, 2. Okay, 0.8643 plus with 0.0012, right? Because this has 2 digits, and hence the probability is 655. So this is what we want. 1 minus 0.8655. That will be the probability. 0.1345. Okay, but it's not done yet. The question is asking you to find the expected number of days during a year. Okay, so what do? We just take 52 weeks, then multiply with 0.1345. So we are getting 6.994, which means expected number of days will be 7, right? During a year for which he takes less than 30 minutes for his run. So expected will be 7 days. All right. So we first find out the probability, then we take the probability multiplied with the total number. So in this case, 52 weeks. All right. Okay, so this is questions from October, November 2013, variant 6.2, question 1, which is similar to the examples we have discussed just now. Do try to find out these questions. And then that's all for these lessons on how to use the normal distribution table to find the probability and answering exam questions regarding expected number. Right? Please subscribe to the channel and like this video. I see you in the next lesson. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses,
please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.